All right, good morning, everybody. So let's go ahead and get started. Today we're moving on and doing a new lesson. So of course we'll warm up real quick. Same thing as yesterday. We're going to check the discriminant and see what that means in terms of zeros and find them. Today's got a pretty easy lesson. We're going to talk about inequalities again. Now you already did it with lines. You know, you shade below the line or you shade above the line. Well, it's the exact same thing here. You're just going to shade above the quadratic or below the quadratic. So it's going to be very, very straightforward, easy lesson for you guys overall. All right, let's go ahead and find some discriminants and stuff on this warm-up. So number one, we got 5x squared plus 4x plus 3. So first thing, let's do the discriminant. B squared minus 4ac. That is what the discriminant is. It's that special part of the quadratic formula under the root. And b is 4, right? So I'm trying to go a little faster on this now. 4 squared is 16. 4 times a times c. 4 times 5 is 20, right? Times 3 would be 60. So 4ac altogether will be 60. And 16 minus 60 is negative 44. So according to your little cheat sheet up there, what does that mean when your discriminant is negative? Thank you, Trista. Very good. All right, go write that down. Write down that sentence right there. 2 complex distinct conjugate zeros. And we'll go ahead and go do the quadratic formula in its entirety to confirm that. We will get 2 complex distinct conjugate zeros. So here we go. X equals negative b for the quadratic formula. B was 4, so negative 4. Plus or minus the square root of b squared. Well, actually, this part of the root's the discriminant. We just did this. It's negative 44. So if you put a negative 44 under the root's negative, that's no good. So make it positive and make it an I outside of it. So something like this so far. And then over 2a. A was 5. 2 times 5 is 10. Now, of course, you want to try to clean up your roots a little bit if you can. 44. Is any perfect squares going to 44? Yes, 4 does. So we will break 44 up into a 4 and an 11, because 4 times 11 is 44. Square root of 4 is nice and pretty. That's why we're doing this. So we'll rewrite the square root of 4 as just 2, just a lone 2 there. And we've cleaned up that root as much as humanly possible. That's a good thing. The only question is, can you reduce this any? I do think that 2 goes in all those numbers. Would you agree? 2 goes into 4, 2 goes into 2, 2 goes into 10. So if you divide them all by 2, that'd be negative 2 plus or minus the square root of 11. I, of course, all over 5 when you divide everything through by 2. And there they are. They're complex, as promised. They are distinct and different. One's positive square root of 11i, the other one's minus square root of 11i. And they're conjugates, because one's plus the I stuff and the other one's minus the I stuff. So there we go on that. Repeating for number 2, starting all over again. Number 2, we got f of x is equal to x squared minus x plus 2. So again, you start with your discriminant. B squared, b's negative 1. Negative 1 squared would be 1. And then minus 4ac. A is 1, c is 2, and 4 times 1 times 2 is 8. So again, in this particular problem, we get a negative discriminant. And that means it has the exact same meaning. That means that there's going to be 2 complex, distinct conjugate zeros. We'll get very much the kind of the same result as we did on the last problem. And when you dive into the quadratic formula, the whole answer turns into this very, very quickly. Negative b be negative 1, so that's just 1. Plus or minus the square root of your discriminant. Your discriminant was negative 7, so again, just call it 7 and take out the I. And then all over 2a, 2 times 1 is 2. There's nothing you can do with square root of 7. Nothing goes into 7, so there's nothing you can reduce. So that's our final answer right there. And that's all there is in number 2. And then one more for good measure, number 3. Number 3, we got ourselves x squared minus 14x. And then you got yourself plus 49 on the end. So let's see what happens on this one. Well, b squared. Oh, b is negative 14. So I got to get my calculator out. I got to figure out 14 times 14 is, turns out to be 196. Minus 4ac. Okay, 4 times 1 times 49. And again, you get your calculator out, you type in 4 times 49, and it turns out to be, guess what? 196. So this whole thing is 196 minus 196 or 0. So this discriminant is 0 this time. And according to your little cheat sheet up there, that just implies that there is one real repeated 0. So that's what you'll write down. One real repeated 0. So I expect to get the same answer twice. And that's pretty apparent if you go to the quadratic formula. X equals negative b. B was negative 14. So negative 14 would be positive 14. But the reason you're always going to get the same answer on this one is because you're always going to have plus or minus the square root of 0. And the square root of 0 is just 0. So really, this 0 up top is going to give me the same answer whether I add or subtract it. That's why we're going to get it twice. And then all over 2a, so 2. 14 plus 0 over 2 would be 7. And 14 minus 0 over 2 would be 7. So no matter what you get x equals 7 in both cases. You don't need to write it twice. That's why the word repeated is there. It's there twice like that. And that's all there is to that. So that's all your training on discriminants and quadratic formula you're going to get. Now we're moving on and doing inequalities with this stuff, which is very, very, very easy. This is nothing you don't already know how to do. Just going to apply it to quadratics. So this should be a pretty quick lesson, I'm thinking. It might.
It sounds like.
Yeah, I don't trust it.
It doesn't sound correct. What did you do?
I didn't do anything. I didn't do anything.
It just, I mean, it's like.
I shut it down one night, and then I come back the next morning, and it didn't really shut down. It like had some instruction memory or something like that. And then ever since then, it's just been.
That's nice.
It did this yesterday too, at like the top of the day, and then it was quiet the rest of the hours. So I don't know.
Weird.
Yeah, I might put in a ticket or just live with it or something.
I mean, it's just like I don't know, just loud.
It is a very loud computer.
Like it shouldn't be.
I agree. It's like
I felt like it's doing anything high.
I mean, is that just the drive running, or is that the fan, or what? I don't even.
I think it sounds like a fan.
Oh well, we'll see.
But I doubt it even.
New homework down there, 3.7. Take a minute, write that down. 3.6 due today. Again, you have the option to do it online or on paper. Either one is acceptable. I prefer paper. I think it'd be better for you, but you do what you want. Oh, are those days gone now?
For the most part, yeah. At least in
No SATA drives anymore.
Oh, there's SATA drives, they're just not hard drives. They're solid state drives.
No.
At least in that, you still see hard drives on like servers.
Yeah.
And desktops.
3.7, 2 through 36 even. Get those taken care of. That's your task. 2 through 36.
Do grade today? May I work on?
You can work. You may work.
Also, can I maybe have an extra day to do this if I don't get it done today since I was gone one of the work days?
Sure.
Thank you.
All right, let's dive right in. So today we are doing sections way down there, 3.6, I believe, or 7 or something like that. Let's see what it's called. Oh, this will be 3.7 today. Quadratic inequalities. Found on page 191 of your online textbook. Yes, you do have an online textbook. So you can always look it up on there and do the problem straight from there. You can, it's the exact same problems are on reveal. So look wherever you want. Should be pretty much the same unless there's a typo or something dumb like that. But I don't know. All right, here we go. There's not really a lot of notes to take today. Here's the one thing I want you to kind of grasp, and that is we're going to be solving quadratic inequalities. So I'll give you quick examples, really, really, really simple. I'll just put it on the board even. I don't even write this down. Let's say somebody asks you to go graph this thing. Now, back on your last test, if the square wasn't there, what would you do? You'd go draw this line, correct? Would it be solid or dashed? It'd be dashed, right? And then you would shade what? Above or below it? Below, right? Why is this? Well, this is absolutely no different. So if they say y has got to be less than x squared, for example, then you go graph y equals x squared. What's a graph of y equals x squared look like? Just like a normal parabola, correct? Nothing tricky. Should I draw it as a solid parabola or a dashed parabola? Dash, yes, I should. So it's the exact same thing. You draw the shape of the actual graph, whatever it happens to be. In this case, it's an x squared thing. Or if it's an x squared, other junk and moved around, you just draw it where it is. And then would you shade above or below? This one you shade below. So everywhere below this dashed line, basically. This entire region in here would be your answer for this particular problem. So you might want to write down an example. That's kind of what all we're doing today. Would be different if it was y is less than or equal to x squared. Would be the only difference. It wouldn't be a dashed line. It'd be a solid line, right? Yeah. So, yep. The solid always means it does equal. So when you put a y is less than or equal to, the equal part's the solid line. The less than is the one shaded below it. That's pretty much all there is going to be to this kind of stuff. But let's look at some specific examples. Of course, if it was greater than, what would you do? You'd shade above. Yeah, so same kind of deal here. Let's try this one out. Graph y is less than or equal to x squared minus 2x plus 8. Probably the hard part is going to be figuring out what a graph x squared minus 2x plus 8 looks like, and then we'll just kind of shade like that. Lots of tools to figure out what this would look like. We can go back to good old completing the square. You don't have to do that, but if you just complete the square on this part and clean it all up, and I'll save you the details of it all, this would turn out to be this right here, x minus 1 squared plus 7 if you complete the square. And the reason I'm completing the square, I chose to do that, you could do a lot of different things, is because it's very easy to spot where the vertex is. The vertex is at 1, 7. So you know this vertex is going to be 1 over 7 up. Right there is going to be my vertex for this thing. I'm going to draw my quadratic solid, correct? Less than or equal to. It's a positive x squared, so it opens upwards. So I kind of boxed myself in here with my picture, but it looks something like this. And then since it says y is less than, you would be shading below it. So very much like the last problem, it's going to be everything underneath this thing, all the way down forever. This would be my solution for this kind of thing. If you didn't want to do a quadratic or completing the square, and I know we hate that, we'd like to avoid like the plague, you can fall back on things from section 1. Way back in section 1 of this unit, there was an equation for where the vertex is, negative b over 2a. And if you plug those things in, let's see, b is negative 2, right? Negative 2 would be positive 2, right? 2a would be 2. 2 over 2 is, guess what? 1. And it says that this happens where x is 1, just like I said. So your vertex is x equals 1. Your axis of symmetry is right there at x equals 1. That's back to section 1 kind of stuff. And how would you find the y value, though? You know it's somewhere on the axis of symmetry right here. But if you know x is 1, then you can plug in your equation. 1 squared is 1, right? 1 minus 2 times 1 would be 1 minus 2, which is negative 1. And negative 1 plus 8 is 7. So you would know it'd be up at 7. So pick whichever way you like. If you want to go back to section 1 stuff, which I bet most of you will do, just use x equals negative b over 2a to figure out where the x coordinate of it is. And then you can plug it back in and figure out the y is. But you need an accurate kind of graph of this thing, at least where the vertex is, so you can shade above and below. So there's the answer to that one. An entire region in space like that. You can always expect that when you have y's and x's. If you have y's and x's, then it'll be a whole shaded thing like this. Let's try this one out. Write her down. Y is greater than, ooh. So this one will be shading above, correct? And this thing will also be a nice little dash line. Dotted, dashed, and stuff like that, because it's greater than. All right, let's see. Well, let's try to go. Let's start off by the graph. What's the graph of this thing look like? Well, probably don't want to complete the square, so let's go ahead and I don't know. Let's do the x equals negative b over 2a thing. Here's your equation for where the vertex is going to be. Okay, what's a, b, and c? There is no c, is there? There's no number on the end. So c is 0, not that it's relevant to this equation, but just FYI. B would be 10, and a would be negative 5. So if you plug everything in, on top you'd have negative 10 for b, then negative b. On the bottom, 2a, 2 times negative 5 is negative 10. So again, this vertex is at x equals 1. So I know over here at 1, there's this axis of symmetry, and my vertex will be somewhere on this. The question is, what y value? Well, if you plug 1 back into the equation, Plug in 1 in for all the x's don't really matter, so it's just -5 plus 10, which is 5. So 1, 2, 3, 4, 5. And that's where my vertex is going to be. Now I just kind of got to draw the quadratic, and let's see, it's a -x² thing, right? So this shall open down. So draw something that kind of opens down like this. And then we're going to be shading everything. Oh, wait a minute, I just jacked up. What did I jack up? Dash, it should be dashed. So I'm just going to erase little parts of it. Whoop, 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 whoop. So yeah, check your inequality, double check that you're shading it right. I can mess it up, you can mess it up, anybody can mess it up. Don't go too fast. And then we're shading above, right? Y is greater than this. So wherever the graph is, we're just shading above it. So here's the graph, everything above it. This entire region higher than it will be solutions for this. So this is always what's going to happen when you have a mix of x's and y's. It's going to be an entire region of things like that. All right, we clear on that? Not that complicated, right? Okay, so mental note, there's two kinds of problems we're throwing at you today. These kinds and a separate one. Now, they look very similar, but you might want to make a note to yourself in your notes. When there's x's and y's, that's when you do shading. X's and y's, you do shading. There's another kind they're going to throw at you. It's not any harder. But they're going to start throwing inequalities at you that only have x's. There will not be any y's involved. Nonetheless, the analysis will be very similar. So if they give you an inequality with just x's, say, for example, this right here, and you don't have to write this stuff down, just think about it. They're looking for when this thing is less than 0. Now, there's no y's, so all we're doing is looking for anywhere where the graph is below. That's what the less than means, right? Below the axis. We're looking anywhere where it's below the axis on the x-axis. So right here, would you agree between these 2 points, the graph is below the axis? Would you agree with that? Yeah. So my answer is going to be that region, that interval right there from x1 to x2, whatever that is. What if it's something more than 0? Well, let's see, greater than 0. That's a terrible. Yes, sir. Yes, I do. Yes, I expected that. Come on in. Have a seat in the back. What's your name again? Brianna, that's right. I just saw that. Yes. Welcome, Brianna. Make yourself at home. We'll get you caught up in just a second after the lessons and all that. All right. So basically, you're just going to shade where it's above and below. It's going to make perfect sense. Let's do this one here. X squared plus x minus 6 is less than 0. If you're comparing it specifically to 0, you want to know where it equals 0. So you got to use some techniques to, first off, I care far more about where it crosses the x-axis on these than I do about the shape and all this kind of junk. So let's see here. Anybody got any clever ways to figure out where this equals 0? There's lots of ways to do it. You just figured out a way. What was the last technique we had? Quadratic formula, right? And I can figure out where it's 0. Don't forget some basics too, okay? Could you factor this and see when it's equal to 0? Yeah, quadratic formula is for when you're in a jam. When you're in a jam and you can't factor it, does this factor anybody? 6, 1? Anybody got any ideas? I would agree with that. X plus 3 and x minus 2. Now, what makes those 0 would be -3, correct? So over here at -3, I know it's going to cross the axis. And over at positive 2, 2 makes it 0. So over here at positive 2 is going to cross the axis as well. I'm obsessed with these. Also, it's a positive quadratic, so it's going to open upwards like this. Now, I don't need a graph for this, because what am I looking for? I'm looking for when this thing, this graph, is below 0, below the axis. Where's the graph below the x-axis? I would think everywhere from here to there, wouldn't you? So you just got to write down this range of numbers. Now, how about at -3? Is it less than 0 right there, or is it equal to 0? It's equal to, so do I want to include that point? No. And similarly over here with 2. 2 is not less than 0, it's equal to 0, right? So you want everything from -3 until 2, anywhere in that region except for the endpoints. That's where the graph is below 0. So your final answer is -3 with a parenthesis to 2 with a parenthesis, because you want a range of numbers on this kind of stuff. Anywhere from here to there, this graph is below the axis, below 0. And that's kind of all you're going to do on these things too. gonna be pretty straightforward. Okay, let's try this one. X squared minus 3x minus 4. They say to do this by graphing, but you know, a rough sketch in your head real quick is probably even better. All right, so this one we got x squared minus 3x minus 4 is apparently greater than or equal to 0. So on this one, again, I would like to graph it roughly to kind of get a feel for where things are. Can you factor this, guys? What would you factor it into? Thank you again. -4 and 1. That does fit the bill. -4 times 1 is -4. -4 plus 1 is -3. So what makes them 0 are 4 and -1 right there. So we got 4 and -1s where it's going to cross the axis. It's a positive quadratic, so it's going to open up. So a rough sketch looks like this. I don't really care what it all looks like on these particular problems because I'm really just obsessed with where it crosses the axis. If we got that, we're good. So the point of this is we're looking for anywhere where this graph is greater than or equal to 0. So anywhere where it's above the axis. Would you agree that it's above the axis over here somewhere? Isn't the graph higher than the axis? Yeah. What about in between them? No, it's below the axis there, right? And then anything past this number, would you also agree it's above the axis? So I need to read off the spots where it's above the axis. Everywhere from the left from -infinity until right here, the graph is always higher than it until we get to this spot right there, which is at what, -1? Should I include -1 for this particular inequality? Yes, I should. Yeah, it's greater than or equal to 0. So this time a bracket on the -1. Then skip over all that middle junk because it's below the axis, right? And then anything from this number, including it on. So bracket 4 to infinity. So my answer would be like this. So what's different between these two kinds of problems? The first kind of problems had y's in them, right? Those are the ones where you shade above or below. When it's just x's, you need to actually graph it and see where the graph itself is either above or below it and write off the x values where that occurs. Making sense? Let's try one more and see if you guys can do it. Try this out. Solve this. It says by graphing. Don't do that. This one's a little challenging because it doesn't just factor right off the bat. And it's got a fraction. That's just pitiful. What the heck is this? Well, guys, you want to factor this? I don't want to factor this. Got this negative thing in front of us. I assume we still hate fractions? Fair? Okay. Would you like to get rid of your fractions? I would like to. How could you get rid of this divide by 4? You can multiply that thing through by 4, couldn't you? Better yet, I like my x squareds positive. Could you multiply by a negative and a 4 to get rid of both of them? Okay, but be careful. I'm going to multiply everything through by -4. What's -4 times -1/4? Well, the whole point of this is so it's 1, right? So we have a 1. So I'm going to multiply everything by -4, including this times -4, including that times -4. And then, what should I write next? Flip the inequality. I'm multiplying the entire thing through by a negative. I got to remember to do that or my answers will be totally backwards. Very good. Now, how about that? Does that look more user-friendly? I like that better, yeah. So if you got fractions, multiply through by them. It's okay. But with inequalities, just never forget if you multiply or divide by a negative, you got to flip it. That's just something you got to always be cautious of. All right, maybe this factors. Anybody? It does. No, it doesn't. I'm stupid. I don't think it factors at all. Well, shoot. How do we find zeros when something doesn't factor? Quadratic formula. Let's do quadratic formula. Let's find out exactly where this thing crosses. Here we go. X equals -b. B is -4. -4 would be 4. Plus or minus the square root of b squared minus 4ac, that whole discriminant thing. B squared is 16, right? Minus 4 times a times c. And that's all over 2a. A is 1, so just 2. Working on the discriminant, the things under the square root, I see two negatives. That makes positive. That's 16, right? So 16 plus 16 is 32. So I have the square root of 32. No wonder I couldn't factor it. Look at these gross answers I'm getting out. I would never have guessed them in a trillion years. Okay, right off the bat, 32 is positive, right? So if I use my little cheat sheet just for thinking ahead, there's going to be two real distinct zeros. They're going to be irrational because the square root of 32 is not pretty. We can simplify the square root of 32, though, some. Any of these perfect squares go into 32. 16 does. Yeah, pick the biggest one. I like that. So let's call 32 16 times 2, because that's what 32 is. It's 16 times 2. Square root of 16 is going to be nice and pretty. It's just 4. That's why we did that. Square root of 16 is nice and pretty. And can you reduce this? Yes, you can. 2 goes in everything, doesn't it? So if you divide everything on top by 2, if you divide this term by 2 and this term by 2, you get 2 plus or minus 2 square root of 2. On the bottom, if you divide by 2, what's 2 divided by 2? Which is 1, right? I'm not going to write divide by 1. That's stupid, you know, or don't ever write anything divide by 1. Don't give me an answer that says 6 divided by 1. I'll come slap you. So there's my 2 answers. No wonder I couldn't figure out how to factor that because those are some gross zeros. Nonetheless, that's all I really need. I don't need to know these numbers. I don't know what they are. I don't care. One of them is 2 plus 2 square root of 2. I don't care where that is on the number line. It's somewhere over here. The other one's at somewhere over here, 2 minus 2 square root of 2. I don't really care where I put them. Would you agree this one's more, though, because it's plus? Right? So it's to the right, and that one's minus, so it's to the left. Now, if I'm analyzing this thing, this altered version, then this would be a positive quadratic, correct? So it opens up, something like this. And I don't really care about the shape too much because I'm really just looking for when this thing is less than 0. And it's less than 0 between these two numbers. Would you agree? Anywhere between there, it's less than them. So even though they're awkward answers, we're going to still use them. We're not going to include the endpoints because we don't want it to equal 0, just less than 0, right? So anything in between them. Parenthesis. 2 minus 2 square root of 2 until 2 plus 2 square root of 2. Anything between those two numbers will fit the bill right there. So yeah, can you get some gross answers out? Absolutely. Quadratics can certainly have gross zeros, but the concept's the same. Once you find them, just think about where it's above or where it's below, and life should be pretty straightforward after that. All right, that's all I got to say about things today. Remember, with y's and x's, those are the ones where you shade above or below. Just x's, that's where you just graph it and find where on the x-axis it meets that condition, where it's above or below. 3.6 due today, 3.7 assigned and due on Monday.